Okay, good morning, all. Welcome to Laksha Academy. This is the part 12 of 20 of excretory products and their elimination. Okay, in the previous part, 19th, this is the continuation of 19th part. In the 19th part, I started this topic mechanism of concentration of filtrate. Okay, mammals have the ability to produce a concentrated urine. Our urine osmolarity is 4 times higher than the initial filtrate formed and 4 times higher than the blood osmolarity 300, whereas urine osmolarity is okay. Urine osmolarity. Can you tell that 1200? And what are the structures that play an important role in producing that? The two structures that play an important role, the Henle's loop and vasa recta, play an important role in the concentrating the urine. The flow of filtrate in the two limbs of vasa recta. Flow of filtrate in the two limbs of vasa recta is in counter current, and the flow of blood in the vasa recta is also in the counter current flow, and these two are also in counter current. These two are in counter current, and these two are also in opposite direction. Okay, that we discussed earlier. And the proximity between the Henle's loop and vasa recta as well as the counter current flow in them help in maintaining the increasing osmolarity from 300 to in the cortex, 300 in the cortex to 1200 in the medulla. Okay, next point. These all points covered earlier. This gradient is mainly caused by NaCl. Who is causing this 1200? Why it is becoming 1200 here? Okay, the two substances that play an important role here in creating this gradient, in this osmolarity gradient. Okay, those two structures are NaCl and urea. How NaCl is transfer, or how NaCl causes this gradient? Okay, let us see that. It is not given in our textbook. This is very important one. Let us take one hypothetical condition, hypothetical state. Okay, imagine that this is the Henle's loop. In the first, when your nephron starts working, the osmolarity in the entire loop of Henle is 300, and outside the nephron, this is outside the loop of Henle, this is called interstitial fluid, interstitial tissue. In that interstitial fluid, in this interstitial fluid also, osmolarity is 300. Now it is our kidney, our nephrons are now working in the first stage, that is. But here, look at the osmolarity here, 1200 here, 300 here, 600 here, 900. Okay, here osmolarity 300 here, 1200. But look at the first condition. Okay, whenever nephron first starts working, juxtamedullary nephron first starts working, the osmolarity in the interstitial fluid, as well as the osmolarity in the filtrate is 300. Okay, this is a hypothetical condition. Imagine so. Then what is happening? Okay, at one point of time, okay, మీ కిడ్నీకి కాన్సన్ట్రేటెడ్ యూరిన్ ఫామ్ చేయాల్సిన అవసరం వచ్చింది అనుకుందాం. Okay, there is a necessity has arisen to produce the concentrated urine. Okay, then what happens is, okay, look at this one, DCT, very important point. Okay, this is the sorry, okay, this is the ascending limb of vasa recta. In the ascending limb of vasa recta, especially in the thick segment, in the thick segment of the loop of Henle, ascending limb of the loop of Henle, in the thick segment there are sodium chloride channels are there. There are sodium channels are there. There are potassium channels are there. Look at these channels. From these channels, what is coming out? Sodium is coming out. Okay, this is the filtrate which is coming down and going towards the ascending limb, coming to from the descending limb and going towards the ascending limb. Okay, in this filtrate there are solutes are there. I told you earlier. Okay, glomerular filtrate consists of water and solute. Okay, one of the solute there, NaCl also present. That NaCl now it is coming outside. Sodium chloride coming through the sodium chloride channels, and potassium is also coming outside. Mainly here we are focusing on NaCl, sodium chloride. When sodium chloride comes out, this is the one fluid. Imagine this is one solution, one fluid. In this solution, what is coming out, either solvent or solute? Solute is coming. That means NaCl is a solute, not a solvent. When the solute comes outside, when the solute comes outside, okay, what happens here? The osmolarity of that solution or filtrate decreases. That means earlier it was 300. As solvent is not coming outside, as the solute is coming outside, the osmolarity in the descending limb only, in the ascending limb only has reduced. The difference here always 200. 200, the difference always here. That means, okay, 200 units of salt come outside, 100 units, then it became 400. Earlier the interstitial fluid con osmolarity 300, now it has become 400. Okay, actually here what is the osmolarity here? Observe here, here osmolarity is 1200, but here now what is the osmolarity right now here? Right now here 400, then it becomes 500, then it becomes 600, then it becomes 700. Finally there is a point, okay, there is a condition in which it becomes 1200. It gradually reaches to 1200. Okay, that is what we talked in the previous part here. Okay, observe this part here. Okay, observe this part, this point here. Okay, the gradient is mainly caused by NaCl and urea. NaCl is transported by the ascending limb of Henle's loop, which is exchanged with the descending limb of vasa recta. I will show you that one. First, what is happening here? What is coming outside? NaCl is coming out. NaCl is coming out from what is this limb? Okay, tell me, what is this one? Okay, this is the ascending limb of Henle's loop. Where is this salt going? Okay, this salt is exchanged with, I will show you here. Okay, now observe this one. This is the ascending limb, loop of Henle, ascending limb. This salt is entering into the descending limb of vasa recta. Descending limb of vasa recta, that is the point they mentioned here. Observe here, NaCl is transported by the ascending limb of Henle's loop, which is exchanged with descending limb of vasa recta. This is the descending limb of vasa recta I told you earlier. Okay, that is that point. Okay, I will come back to this slide. Okay, now it has become to, okay, earlier it was 300. As NaCl come outside, it has become 400 here. But NaCl, when NaCl coming outside, here osmolarity decreases, here osmolarity increase in the interstitial fluid. In the interstitial fluid, okay, the osmolarity increase. In the filtrate, osmolarity decrease. This is the only segment in the nephron which is capable of reducing osmolarity. Here osmolarity increasing, here osmolarity decreasing. Okay, the osmolarity decreasing segment is the ascending limb. Now come here. Now what happens is, okay, this segment I told you earlier, this is water permeable segment. This is water permeable segment. It is made up of, can you tell me, descending limb of Henle's loop is made up of which tissue? Anyone? Okay, a coach universal. Okay, whether you can answer or not. Simple squamous epithelium. It is only permeable to water. Now observe here. As why water is coming outside here? Because osmolarity difference is there. Earlier no water is not coming outside here because there is no difference in the osmolarity 300 here, but here no, you can observe the osmolarity difference here. Here it is 300, here it is 400. Now water comes here. Okay, now water coming here. What is the osmolarity here? 300 in the entire segment, entire limb, entire segment, this segment. But if you come here, as the water is coming outside, here observe the change in the osmolarity has increasing gradually. Now come to this one again. Okay, this is the, okay, again if you observe here, the osmolarity here gradually decreasing. Okay, osmolarity here, when this solution here, what is the osmolarity here? 300. What is here? But here what is this one? This is 400. When this 400 osmolarity filtrate comes here, when it is coming here, observe here, when it is coming here, again some salt come outside, again some salt coming outside. Again the osmolarity has increased from 350, 500. Here earlier it was to 400. And why it has coming now? NaCl is coming. Why NaCl is coming? Here high osmolarity fluid has entered in. It consists of NaCl. NaCl channels opened. NaCl came outside. Okay, right. Okay, now what happened? What is happening here? Now it has become 500. Okay, observe this part. Observe this part. Now more water is coming because more salt has come here. Now again from the descending limb what is coming? Now the osmolarity, observe the osmolarity, it has become 500. Now earlier 300, then it has become 400, then it has become 400, now it has become 500. Okay, why it has become 400? Because water is coming outside. Why it has become 500? More water is coming outside. Why it has become 400 here? Because salt is coming here. Why it has become 500 here? More salt is coming here. Okay, like that. Okay, these steps repeat many times till the point it becomes, till the point the osmolarity here in the inner part of the medulla, when it becomes 1200. Okay, till that point this process goes on. Okay, now finally we reach this condition. Observe this one. Okay, 300. Okay, here 200. Okay, observe here. Here this is the 2 400 100 they give here. Okay, around 100 to 200. Okay, next one 500, like that. Okay, this is 300, 700,000, 1200. Okay, this is in this way this condition is okay, medullary interstitial, medullary interstitial hyperosmolarity is achieved. Okay, here what played an important role? Okay, what is this structure here? I talked about not PCT, not DCT, not collecting that, not it is not a, what is this part? Henle's loop. Henle's loop plays an important role in multiplying osmolarity. Okay, that's why it is a counter current multiplier system. It acts as a counter current because of these opposite current. Here the osmolarity multiplied from 300 to 1200 in the interstitial fluid. Okay, here this is a counter current multiplier system. The counter current multiplier system I covered in the previous part. I told you in the previous part here. Okay, once again I will show you counter current multiplier system. Okay, yeah, is this system includes a descending limb, ascending limb of Henle's loop to produce hypertonic urine. Next, what about the urea? Okay, earlier we talked about here. Okay, two substances play an important role here. One is urea, another one NaCl. Now I told you how NaCl has multiplied the NaCl present in the loop of Henle, multiplied the osmolarity. Here the main thing, the main part that is involved in increasing osmolarity, multiplying the osmolarity, is the loop of Henle. Okay, what is coming out of the loop of Henle here? NaCl. Because of NaCl, the interstitial osmolarity increase. What is the another substance that plays an important role here? Urea. Okay, observe this part. Okay, okay, if you observe the collecting that here there are some urea channels are there, and that the urea is coming from this part, and that urea is entering into this segment. Urea is coming, entering into this segment. That urea goes in this way, again come back in this way. This is called urea recycle. Urea recycle, I will show you the pathway. CD to thin segment, I showed you in the previous parts also, in yesterday's part. Observe here. Okay, urea is coming out from the collecting duct. It is going to the thin segment, then it go to the thick segment, then it go to DCT, then it come to collecting bag. This is called urea recycle. Very important one, urea recycle. Here urea is okay, it is reabsorbed from this segment, it is secreted into this segment. Okay, in that way urea also play an important role. As urea is coming here, here osmolarity increase. Not only NaCl, not only NaCl, urea also plays an important role, okay, in increasing osmolarity. That is the reason why mammals store some amount of urea in the medulla region to increase the desired, to achieve the desired osmolarity to form concentrated urine.